Hello, everybody. Welcome to our monthly members meeting, the first one in 3 years. Is that right? 2 years?
Well, we did our tiny tasting counted. And we had a few,
okay.
Yeah, we had a couple last
Okay,
year.
I missed that one. In any case, welcome. And we're excited tonight to
They're just here.
present Dr. Ramesh Sagili. And he's a really important part of our community. He works at OSU, and he's going to talk about something really interesting tonight. So I'm glad that we're here together. Can you give me the next slide, please?
Yep.
Okay, so you are all supporters of Hub, and let's get more supporters. And so we can talk to our friends. I just put out a little rant on Nextdoor Neighbor and Nextdoor, and I got 600 responses. And so people are really interested in beekeeping and gardening. And so we are kind of community ambassadors as well as loving members. We have all kinds of interesting things that happen in Pub. One, of course, is the swarm list, which is going to start up pretty soon. And we have a new aspect to the swarm list this year. Jana, would you like to tell us about it?
Oh, sure. The swarm list is for anybody who wants to go out and catch a swarm. But the thing we've added on this year is a swarm mentorship. So if you've never caught a swarm and you would like a little support catching your first swarm, you can sign up and we'll partner you with somebody. That Ryan back here is on the list, and I'm on the list as a mentor, and we'll partner up with you and teach you how to do it, and then you can get on the swarm list.
Yeah. Another part of our program is the Bee Buddy program, which is so, has everybody seen the map on the website? It's fantastic. And you can assign yourself as a mentor or a student, and you can see people who are living, close to you. And I've been talking to people about the Bee Buddy program when I visit the apiary, and everybody's excited about it, but nobody's really participating. So let's kind of push that and try to participate if we can. Bee days at the apiary have started in a wonderful way. It's so nice. We're going to have 3 hives out there. And Jenna, do you have anything to say about the apiary?
No, we're there this time of year when it's colder. We're there 11 to 1 on the 1st and 3rd Sundays at 3 acres. And bring your bee questions, bring your bee suit, and bring friends. They're not members. Yeah, they will come one time, and then if they want to continue to come, we just ask them to join up. It's only $25 for the year, so they have a financial hardship. I can talk to them about it, but yeah. They do need us to the minimum projected equipment would be available for opening a hive. But especially if they don't have these, they'll probably recommend the truck. And they have to send me that waiver, so they could go on and send the waivers, or I can take the truck to the
We have some other resources in our club, the library and equipment rental. Those are really important. They're available. Katie's not here tonight, but she hosts a lovely library, all kinds of important books. And the equipment rental, the extractor is now with Richard. Is that right? But we have a mechanical, and we have an electric one as well.
I have Jackie does.
And so that works by, I think you take a little class and sign a waiver on that. Is that right? And then you're allowed to use the extractor. So okay, any questions about things we offer here at Pub? All right, sounds good. My back hurts because I was chasing my kitty this morning and I was bent over while I was running. Bad mistake. 56 years old. Our bee school. is fantastic. And it's our main instructor is here, Susie, in the lovely red top. And Susie actually did a little presentation at Portland Nursery. I happened to be at Portland Nursery yesterday and just asked a couple people, and people were really excited about Susie's presentation. So I know she's a great instructor. I haven't taken the B school yet, but people at the apiary are talking about it. It sounds like a really good program. Her next class is on Thursday, April 13th. And it happens every Thursday night. Is that right, Susie?
No, just 2 more.
Oh, just 2 more.
Yeah.
And people, in theory, they could still join and watch the videos of the same videos of the class. Yeah. And something new to the B school this year, Susie's going to take her students out to the apiary. And so Susie and Jana will be co-hosting an apiary day. And it's going to be a really, really fun and important thing. As you can see, the class covers all kinds of perfect, the perfect kind of entry into beekeeping. It starts with intro and ends with honey harvest. So Susie escorts you through all these important things, and apparently it's really, really important for people that are just coming in. I'm going to be taking it next year. All right. So does anybody know about Dr. Cameron Jack? Do you want to tell us a little bit about him? We almost had him for our club. There was a kind of, everybody puts in a certain amount of money, and if you get lucky enough, you can get the speaker. And we were bidding on Dr. Cameron Jack, but we didn't get him. But now we're going to participate with our fellow club, and we're going to have him on Zoom. So can you tell us just a little bit about?
Yeah, I think he did his graduate work at here at OSU. At the Sagili lab. We could ask Ramesh about him, but I think he's doing his post-grad at Florida State University and doing a lot of research on oxalic acid, among other things, trying to figure out what's the optimal dose of oxalic acid. If you're going to do like a series of treatments in an interval, what's the optimal interval? I think that was last year's study.
Okay.
So
cool. Yeah. Excellent.
So he did his master's at OSU, yeah.
Okay.
PhD at Florida. He actually has a position there. It's not, he was a postdoc, but it is actually a position. He teaches 9 courses.
Wow. That's a lot of teaching.
A lot of punishment.
Yeah.
His work at Oregon was on Nosema. So he's also sold the authority on Nosema. Anyone has a question on Nosema, often he's usually the one to go to now, because we have a different Nosema. His work at Florida was on oxalic, and he's continued that. So real important work on he's been able to demonstrate that the recommended, the label dosage is inadequate for
Okay, good. Thank you. Oh, thank you, Richard. Okay, and we'll send, just like we did before, we'll send the link out to members. Okay. And you say that's on the 17th. Okay, May 17th. Yeah. All right, excellent. Thank you. And we're lucky enough tonight to have Dr. Karen with us, and he's going to talk a little bit about the Pacific Northwest Honeybee Survey.
Well, very little bit, because most of you are participants, and which appreciate. This is another of the services from Pub. The survey is hosted by our website. We've set that up and it has continued that way. So the Pacific Northwest Honeybee Survey is looking at a couple things, looking at how well you did over the winter period of time. So I asked in the survey, it's electronic, I asked how many colonies you have in the fall, and then how many have survived. And then also management. And the management is keyed towards our major issue of why we lose colonies over the winter period, and that's to varroa. So it's a lot of things about grow, about sampling, about what you might have used for non-chemical treatments, for chemical treatments, et cetera, but also about some of your management in terms of what you're doing for winterizing colonies and also what you're doing for feeding. And then what I do is I generate a report for how many recipients I get for the state of Oregon and Washington backyard, and commercials, Oregon, Washington, and Idaho. And then for clubs where I get at least 18 or so returns, I do an individual club report. And I have had that many returns consistently from this particular group. So if you have overwintered colonies, you've not participated in the survey, that's what this is showing. I have just a little flyer. If you have not participated, it's use your search engine, PNW honeybee survey. It's that simple. And it'll get you there, but I have the address here as well. The next slide shows what's happened for losses of Hub members. The solid line is a trend line, and you can see for members of Hub, for records that I have where we've had, again, 18 or more. So we're looking at 3, 6, 9 years of continuous information. You can see the trend line is down, whereas in the state it is flat. Now the trend line is unfortunately is down from what was one of the highest of all of the organizations, 61% loss in 2014. Aren't you glad you didn't keep bees that year, right? Okay. But now at a point you can see a little over 20%. The overall trend line for the state, now that's this group and all of the others, is pretty much flat, right at 40%. Okay, so at present, this group is enjoying a lower level of losses, and that's great news. And then I try to key it to, well, what are some of the things that have changed in this club? And so if you go in and look on the same survey where you take the survey, these reports are located there, and you can see why I'm postulating some of the things that you are doing differently than you did 9 years ago. Maybe some of the reasons why we have enjoyed the last couple of years lower losses. And finally, to give you a bit of the perspective, so on our commercial survey, that's this solid red line here, their average is just over 20%, 21%. The average for the statewide for the state of Oregon is the trend line is essentially flat, and it's just under 40%, 39%. But the blue line here is what was happening with Pub. So you had the distinction of several years of having the heaviest losses of all of the groups. You can see above all, even the state levels of losses. But now, for some reasons, I think we can start explaining with some changes that collectively individuals are making, but collectively we're making a number of these changes. A lot of it related to improving our mite control. You can see we're down with the rest of the fellows, the rest of the groups. So that's great news. So all of this is on the report, as well as those various managements. Questions? PNW honeybee survey. It goes through the rest of this month. Now, some of you may be confused because there is also another survey going this month, April, and that's the Bee Informed program, BIP. They have also a survey. They have, for those that have been on it before and gotten totally frustrated because you just get page after page after page after page of questions, they now limit what they're asking for. So if you've gotten the email reminder, you'll notice that they are promising a lot shorter time to do the Be Informed survey. We're not sharing information. There's a history that's related to that. I hope we will do so. So our information is separate for our group here on the West Coast, so the 3 Pacific Northwest states. Questions? Be Informed, BIP, Be Informed, use your search engine and you'll find that survey. If you haven't gotten an email, for that. Anyone need a flyer as a reminder? Beautiful flyers we've done up this year. I didn't strip it all on fire. Last year I had a relatively low response, not from this group, but a relatively low one, so I knew I had to do something with it. Thank you all. Thank you, Brett.
So without further ado, we're going to watch a presentation by Dr. Ramesh Sagili. Dr. Sagili serves as an associate professor at Oregon State University. Dr. Sagili works with stakeholders in the bee industry, the public through extension, and students to help create a healthy and sustainable environment for bees. Dr. Sagili focuses on research in honeybee nutrition, honeybee health, and pollination. So here we go.
Okay, I'm going to stop sharing, Dr. Sagili, and then you can take over and I'll make sure that you are in full screen. Let's see, I can't hear you.
Can you give me access? Yeah, I think. Now.
Yeah.
Okay, perfect. Yeah. It still says host disabled.
Can
you try giving me access one more time?
Yes.
Yeah, you have to find me in your participant list, I believe.
Okay, yeah, try that.
Okay. Yeah, perfect. Yeah, I think I can see that now. Do you see my screen now?
Yes.
Let me get to full screen. Do you see the full screen now?
Yes, we do.
Perfect. Yeah, thank you. So do I have like 50 minutes, an hour? I'm notorious. I can keep you until midnight today. So
yes, please.
Okay. So you're all ready for midnight?
Yeah.
So yeah, I'll try to be short. And yeah, I have too many slides. That's what I do. And I wish I was in person there. Actually, it's funny. I was in Aurora until 4 o'clock. There was one of our commercial beekeeper had a problem. So we're trying to take some samples and figure out what's wrong with his bees. So yeah, I could have easily driven back to Portland, I guess, and meet you guys in person, but I agreed to be on Zoom. So I came back to Corvallis, sitting in my office now.
Can you hold on for one moment? We're going to, I need to, our speaker is not working at the moment for the group here. Let me.
Oh, is it? Okay. They can't hear me?
That for just a moment.
Sure, no problem.
Thank you. Where's my sound? Okay, can you test it now? Can you test?
Yeah. Do you see my screen now?
Yeah, we do see your screen. I'm just working on the
audio, yeah.
Yeah, on the speaker. Okay. How about that? Can you try one more time?
Yeah, can you hear me now?
One
Not
second.
yet. Okay.
You can hear okay? Okay. Well, I would say if you can hear right for the moment, bring your chair up.
Are you talking about only the Zoom audience?
Yeah, no, I'm talking about just the people in the room.
Oh, in the room. Okay.
It is a Bluetooth. There's not. No, I can't. Yep, it is paired. I paired it earlier. Yep, I paired it earlier. It is charged. I got a full charge. Well, I may just, for the sake of time, let me try one more thing. 1 second, sorry.
Please don't look at her.
Talk amongst yourselves. It's not going to work. No, I don't have that. Okay, I'm just gonna have to ask if you can hear to come up closer to the area. Okay. Okay. Take it away. Thank you.
Are you all set?
Yes, thank you.
Okay. Okay, so I'm gonna talk about two different topics today. I know, as Dr. Karen mentioned, Varroa is a really critical thing, and yeah, I'm glad he was saying as a collective effort, you guys have come down or brought your losses down to 29%, which is really, really encouraging. So yeah, for the last few years, I've been mostly emphasizing on these two topics, Varroa and nutrition management. So I'll try to be brief as much as I can. I know we have a lot of other projects going on, but I'll just focus on Varroa and nutrition. Show you some studies that we have done in the recent past, and then give you some tips that hopefully might be useful for the new beekeepers in the audience. But before I start, I want to acknowledge the support of all these wonderful individuals that you see here, past students, postdocs, and staff that have been really instrumental for the program. So yeah, I just lead the lab, but again, without these individuals, we can't do the research that our beekeepers are looking for. I think you were asking about Cameroon Jack, I think, before. So here is Cameroon Jack. He was one of my students, graduated around 2016 with a master's degree, and he pursued his PhD from Florida, University of Florida, and he's an assistant professor now. So his work mostly when he was here at OSU was focused on nosema. We did some very cool work understanding the dynamics of nosema in colonies. And then he focused mostly on varroa mite management, mostly using oxalic acid at Florida. So I'm glad you're inviting him to be a speaker for your group soon. And of course, you all probably know Carolyn Breeze here, Hannah. Priya was a postdoc. She's now an assistant professor in Mississippi State. Jen, who leads the Master Beekeeper program, and then Ellen, we recently lost her. She went to Cornell for pursuing a higher position than what she was here. These are the graduate students in the lab. Okay, and of course, all the support that Portland Urban Beekeepers Group has been providing us in terms of finances and just the encouragement. And without that, I know no research program will be viable. So really acknowledge your support over the years for our program. So what I'm going to do in the next 45 minutes is go over varroa biology, then give you some treatments, especially for the new beekeepers. Or the veterans in the audience, just be a little more patient with me because I may go into some basics for the sake of new beekeepers in the audience. Then I'll discuss some potential strategies for varroa control, and then I'll switch gears into honeybee nutrition, give you some basics, and then go over some nutrition studies that we have done over the last 5 or 6 years. So here what I've done is just put a colony here, right? So it's a colony survival we are talking about. And as I said before, without varroa management and nutrition management, I don't think you have a good survival. So I know it's hard to just say that, oh, we can manage varroa, you can manage nutrition, but these are really critical ones. And they're hard sometimes, especially varroa management. So again, for the new beekeepers, if you think you want to be successful with your bees in the future, I think these are two important things. You have to take care of varroa and also make sure your bees have good nutrition. These are the two important. There are several other factors too, but these are two really important factors that contribute to your colony survival. So I'll go over varroa mite life cycle. I know it's boring, but again, even for people that are veterans, sometimes we tend to forget much about this meeting is being recorded. So so varroa mite life cycle is really important to understand, especially for new beekeepers. But even those veterans in the audience, I know sometimes we tend to not think too much about the reproductive phase. So I'm gonna show you a study about the reproductive phase as well, so that it keeps you reminding how important it is to take care of varroa mite both in the phoretic phase and also consider what is there inside those cells in the reproductive phase. So I'll quickly run over this slide. So there are females female mites, they will enter into the cells, right? When the larva is about 12 hours before capping. So that means they're about 5 days old larva. And then these female might sneak in, then they hide in there until the cell is capped. And then They start feeding on the larva. So about 2.5 to 3 days after the cell is capped, the first egg is laid, which is a female. And then every 30 hours or so, there is another egg laid, which is a female. So the first one is a male. Sorry if I said female. So the first egg is always a male, and then the subsequent eggs laid by those mites are females. And then males and the male and the first female are ready about a week after hatching to mate. So the reproductive phase, as you all know, they are inside the cells, right? The mites are inside these cells, and they are breeding inside. So you can't really see, and that's the tricky part. So the reproductive phase is something which is always an enigma for us. We really can't see or understand what's going on inside those cells. We don't know how many mites are there. Whereas the phoretic phase, this is how we tell you, right? Or if you read bee books or you attend your bee school, your group is telling you that you should monitor for mites, and you're basically looking at the phoretic mites, which are on the bees, right? So these are the mites that, I don't know if you can see my pointer. So you do an alcohol wash or a sticky board, or you are doing a sugar shake, whatever your method is, you're looking at the phoretic phase, but you really don't have an idea on what's going on inside those cells. So I'm going to show you a study to give you some sense of what's going on inside this reproductive phase. So if you didn't understand anything that I said, so watch this animation for a minute, and hope you'll get all the information that I said before. So here is your hive. There is a bee with a mite, a female mite. So as soon as that female mite finds the right cell with a 5 or 5.5 day old larva, she gets inside and hides all the way underneath. Then once it's capped by the bees, then she starts laying eggs. That's what you're seeing here. And mites are not insects like honeybees, right? So we have a different life cycle. I mean, different terms we use. We don't use larva or pupal stages. We call them nymphs. So here is a deutonymph, a protonymph, and so eggs. So those are the stages of a mite. You don't need to worry about that. So now the female mite, when the bee chews the cell and comes out, you will usually see a female mite that entered, the parent mite, and then there is an offspring that comes out along with her. And if it's a drone cell, sometimes you may see 2 female offsprings coming out along with the mother. So that's basically your reproductive phase, especially for the new beekeepers in the audience. So here is a question for you. So what percentage of mites are there in the cap? Maybe some of you may have seen these slides before. I have put some because I know there will be new beekeepers always in the group, and it's beneficial for them to understand. So bear with me if you have already seen this or have some knowledge of this slide. So what is the percentages? I want you to think. I know I'm not in present there, so probably I can't see your faces and see who is answering, but just think about and keep that in mind, and then I'll show you our study, and then you'll get the answer for this question. So is it 50-50? That means 50 phoretic mites, 50 in the reproductive phase in the cells. Is it 80% outside on the bees, 20 inside? So keep thinking about those numbers. And hope Dr. Karen has a check. I know I heard Dr. Karen in the audience, so maybe he will provide you a check for the right answer.
Yeah, we're definitely going to get it right in this room. I can tell you that.
Okay. So this was done like 5 years ago, I believe. It's an old study. I'm just showing you just to emphasize the importance of this reproductive phase. So you see here, there is our truck. We have the crew here. So this is a very isolated place, 20 miles out of Corvallis area. The reason why we chose is because there is no beekeeper around us, per our knowledge, at least a 3-mile radius around this area. So we didn't want to spread those mites to other beekeepers, because this study involves not treating those hives. Again, don't take this as a wrong message from me here. You have to treat your hives. But this study, we didn't want to treat for mites because we wanted to see the natural cycle of the population growth of these mites, right? So we want to estimate the phoretic phase. That means how many mites are there on the bees and how many mites are there inside those cells. So that was the whole goal of the study. So we had 6 colonies. You may say, 6 looks like a small colony, but you'll appreciate when I show you the study how tedious it is to count mites inside those thousands of cells from each colony, and then also the mites on the bees. So 6 colonies is a decent number for statistics. So So we didn't treat mites until, first we got some APR until March 22nd. From March to September, there was no mite control used. That means we allowed the colonies to grow naturally as they grow, and we allowed the mites to grow along with the bees as well. So there was no interruptions with miticides. So we did monitor mite levels throughout the summer, but then in September, September 14, 2018, we went early morning because September is still warm, right? Bees will fly. So we went around 6 o'clock early in the morning. So most of the bees are still home. And then we took all the adult bees, shook them into these containers with alcohol. I'll show you a video in the next slide. And killed all those all the bees so that you can get the number of mites on the bees, right? And then we collected all those frames with brood and stored them in a freezer so that students can take turns and finish that analysis of mites inside those cells. It took a long time because that's not the only project. We run probably 7 to 8 different projects in a year. So it took at least a couple of years slowly doing everything when we found time for this. So here is how we do it. So we have this funnel. You see this plastic bucket here with alcohol. So bees are all going through the funnel, falling into the bucket, and they die. And then we carry those buckets back to the lab. So each hive will have those bucket full of bees, right? So this is a video. Hope it's running okay on your side.
Another brood frame.
So some of the students are looking for brood and then putting those frames aside. And then we are shaking those bees into these buckets. Looks like this girl is having fun here with those brushes here.
Brush wizard.
Okay, so those are the buckets full of dead bees that we wanted to look at mite levels on the bees from each of those hives. And these are some students looking into those. So we got them this magnifying glasses on this visor here so that they don't go blind. And none of them have sued me at this point. So it looks like their eyesight is still intact. And then you can see those pupal stages or larval stages that they pulled from those cells with mites. So that's how we documented all those mites inside those cells as well. So here is another image of the entire mite family here. This is just from one cell. And this is another almost fully matured. It still is in later stages of development, but you can see those mites on the bees as well when we pull them from those cells. So again, here is your answer. So we got 44% here on the bees and 56% in the brood. Again, don't quote me on this. It might vary depending on the time of the year. This is the time when we did in September in the valley. So that's what we find. But it could vary depending on where you live a little bit. But again, the take-home message is always during the brood rearing season should expect 50% of the mites, at least minimal. It could be even 70, 80% in some cases, depending on the time of the year and how many mites you started initially, right? In March or April. Right now, your count starts now, right? So whenever your bee started in spring, that would also dictate how many mites you will have in June or July, because depends on how many female mites you have, the exponentially the population growth may happen. So that's what you're seeing here in our case. So again, nothing rocket science here. It's a very tedious study, laborious to document, but I think it gives good sense that there is about 50% of mites inside those cells. And the reason why I'm showing you this again is, so you should be thinking about the mites inside the cells as well. I know it's a good strategy to find phoretic mites, either it's 3%, 5%, whatever your numbers will come. It gives you some management ideas, but then you also need to have a good understanding when you are using a product. Suppose you're using a miticide like oxalic acid, right? So it may be only giving you some efficacy for a day or two. So then I know some beekeepers that are new probably may think, oh, I used oxalic acid vapor one time and okay, I might have killed most of our mites. You might have killed majority of the mites on the bees, but think about the bees that are in the brood, right? So if your queen is laying 2,000 eggs in a day, and if half of them are infested with mites, so there are 1,000 mites probably available tomorrow, right? So think about, again, don't quote me on the exact numbers. I'm just giving you some vague examples. So there are mites emerging every day. So that's what you have to think when you use a miticide that has only an efficacy period only for a couple of days or a day, then you have to repeat the application either after a week or 10 days, depending on the product. So that's what I want the new beekeepers in the audience to take away from this slide is think about your treatments when you use and think about those mites that are in the cells in reproductive phase that you have no idea about. So here is that take-home message here. More than 50% mites are in the cap brood cells during brood rearing season. So that's what I mentioned. You should keep that fact in mind when you're using your treatments. So a little bit about mite sampling methods here. So you can see there is alcohol wash, sugar shake. You might have already used out some of those. Alcohol wash by far is one of the superior methods, I would say. Sugar shake is also pretty decent, very close to alcohol wash. Sticky board just gives you a broad idea, but you can't get real percentages, like how many percent, like if you have three mites per 100 bees, that's your 3%, right? So you can't get that kind of numbers with a sticky board, but it's a good tool. It's not intrusive, right? You don't have to go into the colonies and sample bees. And you just put a sticky board, and after 24 hours or 48 hours, you can pull it and see what your mite levels are. It gives you a good sense, but still not an accurate way to look for mites. Then there is carbon dioxide as well. Some people use, and it's also an effective way, but it's not as good as alcohol wash either. So I just put a strategies here, like a couple of them, nothing rocket science, as I said, but for new beekeepers, it's really important to understand. So frequent monitoring, I can't emphasize that. Probably your group has already said, and I know Dr. Kevin speaks to your group often. Monitoring is really important. And in one of his slides, he was saying, varroa mite really dictates how your colonies will fare during winter. So frequent monitoring is really important. And sometimes I know some beekeepers I see, we treat our mites in August or September, but that's too late sometimes because again, each year is different. This is another weird year we are going through. Some commercial beekeepers have been struggling in almonds. So we'll see how the mite year goes this year. But each year is very different depending on how soon the spring starts, how soon the brood rearing starts in your hive, depending on the spring as well, right? So those are different things. So don't think each year is same and you just have a date to treat your mites either in June or July or August. So you have to monitor, and based on that, your management has to advance or delay. That depends on your mite level. So please keep monitoring. I know it's a little tedious, laborious work to do, but again, varroa really is a problem. I can't emphasize more. So please monitor your hives, and based on that, do some control measures. So that's what I say here. Instead of calendar-based varroa treatments, we should be focusing on the population dynamics-based treatment. That means by monitoring and seeing when your levels are high. So suppose if you're treating in September or August, and then you think we are getting rid of all more mites, but your winter bees are really, really important. I'll not talk about winter bees today much in my nutrition one, so I'm gonna spend a minute here to emphasize how important those winter bees are. So winter bees are no special bees. They are the same bees, right? They are laid by the same queen, but their physiology is different. At that time, those bees that are being produced or made, they are not eating, they are not feeding that much larva. So whatever protein, the pollen they are eating, they are incorporating into their bodies, right? So it's an endogenous sterols, and everything is being vitellogen, and they are just accumulating those proteins and fat bodies, and they're growing those fat bodies in their abdomen in winter, before winter comes. So those winter bees are really critical. If the varroa mites have really done a physiological damage by feeding on those winter bees when they were being raised, then those bees may look okay to your naked eyes, but they will not survive too long. They will all be dead by December or January. So because their immune system is already compromised with those varroa mites when they were either in developmental phase or even after they came out of the cell. So those winter bees are really critical. That's why the varroa mite management really becomes important. If you are not doing your treatments on time, and if that is impacting the winter bees, then probably you will not have a thriving colony by December or January. So that's why it's very important to manage those mites. So there are ways, I said, there's alcohol wash. I'm just showing you some images here. You get a percentage of mites. Sugar shake also gives you a percentage of mites. These are the sticky boards that I showed you. Again, I'll not We have YouTube video where you can watch, or you can just Google for Oregon State University Honeybee Lab, and you can find those videos, or you can even Google for sampling for varroa mite / Oregon State University, and we have some good videos for you to watch on how to do this alcohol wash or sugar shake method. Strategy 2, use combination of available mite control products. I know as beekeepers, we don't have too many tools in our arsenal to really control mites, but whatever tools we have, we should be able to use them in a more effective way. So there are some examples like amitraz, which is a synthetic miticide. There is formic acid that you can use in summer or fall. There is oxalic dribble in winter. You can use oxalic as vapors now in spring or summer. So I have an oxalic acid study, so I'll go in more detail on oxalic acid at that point of time. But again, the strategy here, monitor mites after treatment. And again, I said monitoring mites is important, but this is something different I'm talking about here, right? Monitor mites after treatment. Sometimes we just assume that whatever treatment we used is gonna work. Sometimes it doesn't, right? So that then you are too late. Suppose I use amitraz maybe in spring or maybe in fall, like August or so. And then if I assume that my mite levels are all being taken care of, and then I don't do anything until October, then I just am assuming that the treatment is working, right? If it doesn't, then if you have done a check on the treatment looking after a month, suppose I sample today, and then after treatment after a month, then you will know if the numbers are changing or not. If they are just increasing or stable, then you have to worry that maybe the treatment hasn't worked, and you may look for some other options. But if you are not, and you're just assuming that the whatever treatment you used is working, then you have lost the opportunity to rectify that problem. And that, again, as varroa mites, they're not just only feeding on the bees' abdominal fat bodies and some degree hemolymph, and they're transmitting viruses, which becomes a huge, huge problem. Actually, viruses are really more devastating than your mites just feeding on them and damaging those fat bodies or the physiology. So we also try to look at the efficacy of the treatment. So once you apply something, after a month, check on your mite levels again. The last thing I would say in the strategy here for mite management is to avoid mite migration between hives. If you have one colony, you're fine. But if you have 5 or 6, sometimes each colony may have a different mite level, right? So if you think, oh, I only have high mites, like 5% in this one hive, and you treat just one, I think it's a good logical way to do it. But I think many studies have shown, or at least something we have done here at OSU, documenting migration. I say that treat all the colonies in your apiary, not just one, if you're treating, because one may have a little lower levels, but eventually they may all get from other hives around you. So try to be on top of it and treat all the colonies rather than just 1 or 2 in your apiary. So just to back up what I said, mite migration, not many of us think about mite migration, right? So the new beekeepers, don't get confused. Mites can't fly, but they can fly along with the bees, right? So your bees are drifting. Drifting is a big thing. I mean, just again, I'm not in front of you, so I can't see your faces and ask you questions, but just think about how much of a problem is drifting. People think drifting is not bad, or our bees are pretty good. They can smell other bees. They don't allow other bees. That's a fact. Bees will not allow other bees to get in, but still there is a significant amount of drift. Sometimes if a bee comes with nectar loads, then they will be allowed in. And nectar foraging time, bees don't pay that much attention. If you're an intruder coming with nectar, they will allow you in sometimes. So then if that bee had a mite, then you are carrying a mite from a different hive into this hive, right? So migration is a problem. And we wanted to document this in Central Oregon Madras, where commercial beekeepers go in big numbers for pollination of hybrid carrot seed. So we thought this would be a neat location to look at some of these problems. So here you see, I call it a low bee density location. So it's the same beekeeper. So there were about 6 beekeepers in this study. And so we chose the same beekeeper for these 2 different locations. So suppose there is one beekeeper A goes to low bee density, the same beekeeper will go to high bee density area as well, because we didn't want any other variables added to their management practices that would screw or skew our study, right? So we didn't want that. So here you can see the low bee density means there are no beekeepers around that beekeeper, at least for a 3-mile radius. So that's what you're seeing here. So in early July, we sampled, we got a 1.3%. And then late July, when they were leaving, almost they leave around August first week. So within that 3 or 4 week period, you can see there's not much of a change. But as here you see the high bee density locations, that means a beekeeper is just few hundred yards from the other beekeeper. So there is a high density of bees in the same location. So here you can see how much drift happens because you're seeing the mite levels go from 0.5% to 1.1%, almost double, right? So this is a good indication that mite migration is a problem. As hobby beekeepers or backyard beekeepers, you don't have to worry that much. But for commercial beekeepers, when they keep bees in high densities in some locations, that's a huge problem, mite transmission between colonies. So that's what I was emphasizing, that mite migration could be a problem in some locations as well. So here are some treatment options. I'm not going extensively into anything because of time. So I'm just showing you some important ones that are being used by beekeepers and are really effective. APR, which is amitraz. There is Formic Pro, which is a formic acid. There's APGuard, which is a thymol product. And of course, you all probably are aware of oxalic acid, which you can use as a dribble or as a vapor throughout the year now. So on the right side, what I'm showing you is just a sample treatment that we use here at OSU. And I think this has been a really good sample treatment regimen for us. So again, you can use some of these same rotations, but again, this has worked for us, but doesn't mean that it will work for you as well. So we use APR in the spring, then we use a Formic Pro 1 pad because 2 pads might be too much for sometimes with some brood damage and maybe some queen issues. So depending on the weather, if it's too hot, then we use only 1 pad application twice. That means every 10 days, right? 2 applications. And then Formic Pro again, if we want, we use again if we find some good, not so high temperature days around July as well. And then in the fall, we again go with APR. Again, this could change every year. I'm just showing you one sample treatment here. And then we do oxalic dribble probably November, December when there is minimal brood or no brood. And that has really worked well for us. So again, you can try different combinations. Each area is different and that depends on how your beekeeping style is. So again, do something for your bees. I'm just giving you some examples here. I'll switch gears here into oxalic. Probably some of you are very curious about how oxalic works and what's the correct dose to use. Because currently the registered dose, at least the label dose, is 1 gram per brood chamber, right? So for new beekeepers, when I say per brood chamber, means if you have brood in 2 boxes, then that would be 2 boxes would be 2 grams dose for that hive. That's a label direction. Again, I'll show you that that's not the right dose. It's very low. It's not working to give you an effective varroa control. So we did some studies, and based on that, I'll give you some recommendations at the end. So how many times can you use? I think that's another question. Probably most of you are thinking, you might have heard, oh, oxalic looks like an organic type product, but if you use 5-6 times in a year, maybe it damages your brood, it damages your queen, or it damages your workers as well. So we wanted to look at some of that aspect as well. So we did actually in 3 different years. So I'm going to only talk about what we did last year. You probably heard me in the past if you have attended the Oregon State Beekeepers Conference, or maybe I spoke to your group last year. I am not sure if I talked about this. But because of time constraint, I think you still will get a good information on the past studies as well based on our last year's study. So in 2019, we looked at some larval mortality testing with 1 gram dose. Then we figured that 1 gram is not the right dose. It's relatively low. So we tested other doses in 2021, 1 gram, 2 gram, which is double the dose, and 4 gram. Again, 1 gram per box, 2 grams per box, 4 grams per box. So if you have 2 stories with brood, then this is 8 grams here, right? And in 2022, based on what we found in 2021, because we were finding a little more mortality with larva with 4 gram, so we thought of testing something to find a sweet spot between 2 and 4. So we used a 3 gram in 2022, and we also again used 4 grams. So I'm gonna show you the study results for the 2022 study. Hope you are still able to hear me well in the audience there. So here is a 2022 oxalic vapor study. So we tested 3 gram, 4 gram per brood chamber. So these were 3 applications. You may ask why 3, why not 5? So based on what most of the beekeepers are doing, we just wanted to stick with 3 applications, 1 week apart. So these are some things that we measured. We looked at mite infestation using alcohol wash and sticky boards, colony evaluations, looking at number of bees and brood, worker bee samples to look at oxidative stress. That's a physiological stress. And then we also looked at any damage to appendages. And then we also collected queens from those hives to see if they had any problem with their semen from the spermatheca. So we have some results for those, but not for those worker appendages. I'll show you some of those. So the methods you can see here, how we used, because I have to burn 8 grams into one hive, right? So I can't go like 8 different times. That will skew the experiment because of other variables. So we use 2 battery sets here. So there is 2 gram burning here, 2 grams here, so 4 grams at a time. So you use this wet towels. So if you use oxalic acid, be mindful, close all the entrances. So we have closed all those auger holes and make sure that the vapor stays in there for at least 10 minutes. If you're just using it with a screen bottom board or something, then it may just, the vapors may go away and the product may not be very effective. So, I mean, with this, even this wet towels, you'll see some product coming out, but it's not that bad. So you can see in this video here. You see some vapor still coming out. So hope you were able to see that video. So here I'm showing you the sticky board drops here. So I think most of you are interested in how many mites drop in first day, and some beekeepers have been asking how many days that the treatment work. Does oxalic vapor stay in the hive enough on the bees, on the comb, maybe recrystallize, and it's effective for several days? So that's what we wanted to know, right? So here you can see this is your 4 gram treatment on the top here, the gray bar. There is green one with 3 gram. The yellow one here on the bottom is your control, no treatment. So you can see there are about 1,400 plus mites dropped on the first day in these hives. It's an average for several colonies, at least 8 colonies that I'm showing you here. So here with the 3 gram, you're dropping about 800, and controls probably not much. So you can see even after day 1, like this is day 2 here, after 2 days, you're seeing still some drop, about 400 mites with the 4 gram, 200 with the 3 gram, and this is control. And then by day 3, end of day 3, this is not much. Everything is getting closer here, right? There's not much of a difference. So it looks like oxalic, most of the drop happens after you use your vapor is the first day, and then you still get some efficacy on day 2 as well. But from day 3 on, there's not much happening in terms of oxalic acid efficacy. So I'm showing you the week later because we applied 3 times, right? This is the second application. So this is the proof of what I was talking about, right? If all the mites were gone in your hive when you applied the first treatment, there should be no more mites left here, right? But you're still dropping even more now, more than 2,000 mites dropped in those 4 gram treatments, and about 1,000 in this one, and control was here. And then you still see the same trend. You're still dropping mites until day 2 a little bit, but from day 3 on, again, it tapers down. So I'll skip this one. This was from previous year. So we did some meticulous monitoring of larvae as well. So we picked some 2-day-old and 4-day-old larvae with a transparent sheet. Unfortunately, I don't have an image here to show you, but we place it on the frame. We mark those hives with, the larva with a marker, and then we can put that acetate sheet back again next day to look at if how many larvae are dead or have been removed. So here you can see, this is just a trend. We haven't done a statistical analysis yet, so I can't tell if they're significantly different from each other. By just looking at error bars, you may make some inferences, but this is just a trend. So So you can see the 4 gram looks like it's doing some damage to the larva, right? Whereas 3 grams is not very different from the controls. So again, just basically looking at the trend, not looking at the statistics at this point in time. So take home message, oxalic acid 1 gram is safe based on our studies, but again, it doesn't really do much of control for mites. So again, at this point, unfortunately, as a researcher, I can just say it doesn't work, but you still have to follow the label. But hopefully the studies that we have done here and the ones that Cameroon and others have done in Florida with oxalic, they have shown the same thing. 1 gram is not the right dose. So hopefully there will be a label change in the next couple of years so that it reflects the correct dose. So that's what I'm saying. The current global label dose of 1 gram appears to be inadequate for control. 3 grams based on our study looks like an effective control, and you don't have that much brood damage as well. So it looks like relatively safe to larvae and bees. So again, oxalic is a nice product. You just have to use it at the right time and use it the right way to get a good control of your mites. So this is something for the future. So we have a glass hive design because there is so much of the chemistry part we don't know about oxalic. Does it recrystallize on bees? Does it recrystallize on the comb? How does it really vaporize inside a hive? So we did some initial trials last year, but we'll be doing more this year. So that's why we built this glass hive so that I can see what's going on inside those hives when we use those oxalic acid vapors. So again, for new beekeepers, there is a great varroa management tool from the Honeybee Health Coalition. Dr. Karen is the primary author on that one. So hope you all know about it. They have some cool videos and a lot of good information about all these different treatments that I mentioned before. So yeah, at your convenience, look at those videos at this website. So I'll switch gears and let me ask you, how much time do I have? I know we started a little bit late. Can I go another 15 minutes?
Yeah, sure. Go ahead.
Okay. So this is honeybee nutrition is another prime area of research in my lab. So we have been working on several research projects related to nutrition for the last 5 or 6 years now. So I'll show you a couple of studies and give you some basics on nutrition as well, especially for the new beekeepers. As I said, varroa is one of the most important ones as management to be a successful beekeeper, and nutrition is the next one. So be mindful of these 2 different topics. So as the adage goes, nutrition is the first line of defense, and we all hear that you're what you eat, and so it's true for bees as well. Their diet is really dictating their immune system as well. There are so many studies that have shown that nutrition will boost their immune system, that helps with detoxifying enzymes and all those different things. Again, I'll not preach again, same things. You probably all know the importance of nutrition. Just wanted to, for the new beekeepers again, colony nutrition is, again, before I even go into this slide, and you'll be surprised when I say, we understand more about grasshopper nutrition better when compared to honeybees, right? Isn't it surprising? Honeybees, the most advanced social insects, have been studied in the modern world for at least more than 200 years rigorously, but still we don't have, we have barely scratched the surface in terms of nutrition, whereas we have very good understanding of nutrition for some solitary insects like even grasshoppers. So you'll appreciate when we talk about the complexity. The reason is it's not like no one wanted to study. It's very complex to study honeybee nutrition because it's not just one simple thing, right? There is a colony level nutrition because your colony as a whole is one social organism there. And then you have adult nutrition, which is different, right? Your foragers that bring in pollen, they never eat that pollen. The nurse bees are the ones that are about 7 to 14 days old, very young bees in the hive. Those are the ones that are processing that pollen, right? They are eating the pollen, growing those hypopharyngeal glands and mandibular glands, and those glands are the ones that produce food, or the brood food for the larva. So the nurse bees are the ones that are eating protein. So their protein needs are relatively high when compared to your foragers. Foragers are relatively old. They are more than 3 weeks old. So they are not looking for too much protein, right? They are only looking for a little bit of protein, but mostly carbohydrates from the nectar to fly, because that's a very energetic process, flying back and forth from the hive to get pollen and nectar. So again, within those bees, right? I'm just giving you one example, pollen forage, the nurse bees and the foragers. So even between those, there is a lot of difference between the nutrition, right? So adult nutrition, and then your larva, they have a very different diet. They're not eating the same what your bees are eating. They're not directly eating pollen. They're dependent on the brood food that is being produced by those two glands, the hypopharyngeal glands and the mandibular glands. So larvae have a different diet. Whereas if you think of a grasshopper, the nymph or the young grasshopper is eating the same as the mother, right? They're the same. Whereas in honeybees, you see how it's complex. The larva diet is different. There is difference in diet between nutrition and between individuals. And then also there is this colony level nutrition, how much pollen we have, how much nectar, that also dictates your colony status. So again, there are 3 levels of nutrition in honeybees, and that makes more complex to really understand the requirements. But that doesn't mean that we can't figure out what bees need, but I'm just saying it's very difficult and complex. So here is a very simplistic explanation of honeybee nutrition. So here on the left of this white bar, I have macronutrients. Macro means large, right? So they need large amounts of these. And then we have micronutrients. These are required in small amounts, like your vitamins, minerals, and there are lipids, especially sterols, really important. I'll focus on this in the next couple of slides. So macronutrients, we have good understanding of macronutrients, I would say, right? If you ask your group or ask me, we'll say in the valley, you need about 70, 80 pounds of honey to survive the winter for each of those colonies. And then we know this much of pollen you need. So we have good understanding of carbohydrates and proteins, but these are the ones that we have probably, I would say, a very minimal understanding of micronutrients. And that's what we have been doing at OSU in the last few years, is trying to understand the micronutrient requirements, especially the sterols. So for new beekeepers, again, pollen is the protein source. They don't get protein from anywhere else. Pollen is the only source. They don't get anything. We can eat beans if you are vegetarian. We can eat meat to get protein. But for bees, pollen is the only source for protein. And the pollens are very different. Each plant is different. So they may vary anywhere between 10 to 40% crude protein, depending on the plant species. And again, nutrition is really important. As I mentioned, while talking about bromites, those winter bees that are raised probably from August on in the valley, August, September, October, those bees are called winter bees. We use a Latin term, diutinous bees. Diutinous means long-lived bees. So these are really important. So even if you are compromising their nutrition when those winter bees are raised, that's another red flag. Your colony will have a serious impact. So both bromites and nutrition are really critical when they are raising those winter bees. So be careful about those two aspects and get those really healthy winter bees that will thrive the winter and be there in spring for you to establish the colony. So I'll talk about these lipids. So these are all different types of lipids, but I'll focus on sterols today, which are really important because they are responsible for the molting hormones. So sterols are required in all insects, and even we need sterol, right? Your sterol is cholesterol. So cholesterol, people will think it's bad, but you really need cholesterol. Without that, there is this, they are like in insects, they are components of cell membrane. They are precursors of molting hormones. They have similar functions, not molting. We don't molt, right, humans, but we have other functions for cell membrane development. You need that cholesterol. Too much cholesterol is bad. Maybe it blocks your arteries. Similarly, the insects have a different sterol they need. We call, in case of honeybees, it's a mouthful. It's called 24-methylene cholesterol. So this cholesterol has to come from the pollen. So if your hives are struggling in terms of pollen, that means they are not getting this adequately, and then you will see the colony growth literally stops sometimes if you don't have pollen coming into the hives. So molting hormones, if you still have some, you remember your high school biology or wherever you studied about molting hormones. So these are two important molting hormones in insects, ecdysone and juvenile hormone. So there is a beautiful interplay of this ecdysone and juvenile hormone. So if juvenile hormone goes up, then the larva stays in that stage for that period. And when the juvenile hormone goes down, then ecdysone goes up. Then the larva will molt to the second phase. That means 1 day old will become 2 day old, 2 will become 3. So these 2 hormones are really important. And those 2 hormones are really dependent on those sterols that I talked about. If you don't have the 24-methylene cholesterol, you will not have these hormones. And you'll be stuck in that phase. If you are a 1 day old larva and there is no molting hormone happening because of the 24-methylene cholesterol, then your bees will cannibalize you, thinking that you are no good for the hive. So that's a problem. The colonies will not grow if you don't have that. So if you didn't understand anything, again, as I said, just watch this animation if it's working on your side. So here is a pollen grain. We are animating, showing it as those sterols are pollen sterols showing in pink here. So bees will eat the pollen. They kind of internalize it. So that means it gets into endogenous sterols. So now when the bee feeds those larvae with the brood food, so they also transfer that sterol to the larva. So now the larva has beautifully grown into this adult bee. So you have no issues. So again, this is not a great example. I'm just showing you protein supplement here, assuming that protein supplement is not mixed with any pollen. It's straight protein, whether with your any of those ingredients, either soy flour or whatever it is. So you're not having any of those molting hormones because the bee didn't get any of those sterols into the body. And so this larva desiccates because there is no molting hormones happening in this. So that's what happens if you don't have sterol availability in the hive because there is a lack of pollen. So again, I'll not bore you with all the study details here, but we have done some important work looking at the requirement of this 24-methylene cholesterol. Some studies have shown the importance, but we didn't find any study documenting the real requirements, like what percentage of the diet should be 24-methylene cholesterol. So this is a study that we published a few years ago. It's an open access. You can Google either my last name or my postdoc. Now she's an assistant professor, Priya. So, and find the study, or else you can email me and I'll send you the study. And then there are some studies from Europe as well, where they have shown the importance of omega-3 fatty acids. I know some of you probably eat the fish oil, right? The capsules. That's basically your omega-3 and 6 fatty acids that you're getting. So some of the studies have shown these are really important for bees as well, in both their memory and also, mostly they have shown the importance of these omega-3 fatty acids in their memory. So again, micronutrients are really important, but we have barely scratched the surface to understand their requirements in honeybees. So you may ask, like, oh, you know, we are doing all these basic studies, but the whole goal for all these basic studies on micronutrients is eventually, I know it's a very ambitious goal, but what we envision from all these studies is to improve the existing protein supplements, because now we have some good supplements that are sustaining your bees, but they are not very balanced diets, right? They are only providing your crude protein because we don't have good understanding of sterols, omega-3 fatty acids, several other micronutrients. So eventually the goal is to figure out what are the requirements, and maybe then we can come with a more balanced diet. You will never come close to pollen, but still the whole goal is to strive as much as possible to get to the goal where we can provide some balanced diet to our bees in the future. So I'll switch gears and give you some more field studies we've done in terms of bee nutrition. So this is just a slide to show you. It may not be really applicable to you as a backyard beekeeper, but for commercial beekeepers that move their hives every month to a different crop, sometimes this could be a challenge for those bees. Lack of pollen abundance, right? Because they may not get enough pollen. Like they put their bees in hybrid carrot seed in Madras, Central Oregon. Hybrid carrot seed doesn't produce much pollen and nectar. So bees are really stressing in terms of nutrition when they are there in Madras. So that's an example of lack of pollen abundance. Then sometimes we encounter lack of pollen diversity, like you are in almonds, there is nothing else in bloom. So it's only almond pollen that is coming into the hive. So that's an example of not having a diverse pollen, because studies have shown diversity also matters because each pollen is different. If there is an amino acid missing in this pollen, it may be present in that one, right? That's why when you sit next to a hive, you see these bees bringing in pollen of different colors. They have evolved for millions of years collecting those different types of pollen, because bees can't really tell which pollen has more protein or all amino acids present. So that's why they do this mix and match. Of course, if they don't have any access to other pollen, they're gonna just bring one source, which may not be great for the hive. So think about pollen diversity as well. And then of course, pollen quality is important as well. If the crude protein is low, like if you look at some of these wind pollinated crops like willows, they have shown to have lower protein content, like 10%. Whereas your tree fruits like your apple or cherries have something close to 24% crude protein. So sometimes that quality of pollen also matters. So we did some studies. Again, because of time, I'll not go into too many details here, but we did a study a few years ago looking at pollen diversity available to bees in cropping systems. So we looked at these several different crops here. You see almonds, blueberries, carrot, cherries, and meadowfoam. And you can see almonds, you get a lot of pollen. So this is grams per colony per week. Like you are in blueberries, it's not much. Carrots is still horrible, 14 grams. So there is not only a difference in the amount they bring in, but then you can see the diversity as well, right? Here you can see the diversity. So in almonds, there is not much else blooming in almonds. When almonds bloom very early in the season, like February, so there is not much except for a few wild mustard around or some dandelions. But when you get into blueberries, you see a lot of diversity because it's spring. There is a lot of other things blooming, but unfortunately, the pollen amount is coming low. So sometimes you may think diversity is good, but then you have to look at the abundance or the quantity as well. If the quantity is low, even the diversity will not give you much of a benefit, right? So again, just showing you nothing really groundbreaking here as a hobby beekeeper for you, but just be mindful that pollen that is coming in is really critical. The abundance is important, and to some degree, diversity is important as well. So I'll switch gears again here, and probably you have heard about this before. So we have a USDA project that was funded a couple of years ago. So I need some help from you guys if you're interested this spring and fall to collect some pollen for me. You can email me. I'll send you more details on how to be a part of this citizen science project if you are interested. So, but again, the whole goal is habitat improvement for bees, right? You have heard of all this, maybe in Portland. Maybe this is a picture from Portland area. You probably see some signs, pollinator habitat, even in agriculture areas. We are trying something with carrot seed producers. You see this hybrid carrot on the background. Here you have some bacillus button in bloom here. So there are efforts being done both in urban and ag landscapes to see if we can improve habitat for bees in terms of nutrition. But what we proposed here with this proposal is we want to develop a pollen nutritional composition database where we will tell you, like for each pollen, we will come up with all the lipids, all the amino acids, how much crude protein is there. So because right now what happens is there are beautiful lists. Probably Glenn Anderson is probably on the Zoom or somewhere. I saw his name. And I know he puts his list of bloom, right? It's beautiful. I really like the list of plants he gives you, what is blooming. And we need that kind of information. But what is lacking in terms of many of the lists that Xerces Society has or NRCS, they have done a great job of putting all this, right? I'll show you that in a minute here. So you see this list here, right? This is from NRCS website. This is the Xerces website. So you have all this beautiful information of when you can plant things, when do they bloom and all for bees. But wouldn't it be great if you have more information on the pollen nutritional composition as well, like how much crude protein is there in one of these species that you're picking, so you can make a better judgment on what you plant in your backyard. So this information is missing at this point. That's why we have gotten a lot of attention from USDA programs and others. They are really excited about this project. So I would urge you, if you're interested in helping collect some pollen, email me and I'll give you more information on how to help. I'll go back to the slide because I didn't show you the real goal behind this. So all those lists that I showed you, those are really great. I'm not discounting, don't get me wrong. We need that kind of information. But wouldn't it be great? Because right now, it's all about attractiveness, right? We have this plant, a lavender in your backyard or bacillus button or borage. You see a ton of bees coming to those. but that doesn't mean that's the best source for your bees. So I'm giving you a lame example here. I have this French fries here on your left and your salad on your right. If you put these two together and give me at the same time, I may start eating French fries first, right? Because it's attractive. So this French fries are attractive doesn't mean they are really great for my health when compared to the salad that I see on the right, right? I know it's not a great example. I'm just giving you some lame example for you to get the message across. So most of these plant lists are based on attractiveness at this point. So we want to have that information of pollen from those species. You may say, why not nectar? That's again an important thing, but that's something, even with this pollen, it's a very ambitious project. So collecting 1 gram pollen for the study is really, really hard. And I'll show you some slides, what we are doing what we have been doing in the past. So again, so I'll tell you a joke here because it's night, you probably are sleepy. So I was showing this slide at a different group a few months ago, and one of the guys said, yeah, you are gonna eat the French fries first because they will get cold sooner than your salad. So, okay, that's enough jokes here. And watch this video. It gives you some sense on how you can help us with the pollen collection. Hope the video ran okay on your side. So that's how you can help us with collecting from honeybees only, no bumblebees, because honeybees are, probably some of you know, they are very floral fiddle. That means they have this floral fidelity or floral constancy. They keep going to the same species for the entire foraging trip or until the entire resource is gone. So there is a less chance of contamination of pollen from a different source. So that's why we are only targeting honeybees here. So if you think there is a significant acreage of some crop or some plant that we may be interested. So I have a list of plants that we have proposed. So I'll be glad to share that list of more than 100 plant species that we are looking for. So if you have something very unique in your area and you want to help with that, so either you can help via honeybees or you can do a hand collection. So here are some methods that I have shown. I know they're very tedious, but I'll send you a video. And we have a vacuum device that one of the graduate students has designed with different mesh sizes, because pollen comes in different sizes. So there may be something like from 15 micron to 170 micron as well. So we have tweaked around and finally came up with a good design with this vacuum. So I'll be even happy to, you can borrow this vacuum device from us as well, if you think, but you have to promise me that you'll get a gram for our study. So that's the whole trick. So yeah, feel free to email me. I'll give you, with this, I don't want to advertise too much of the study and for not bore the people that are not interested in this thing, but we are really looking for some help with this. So I have some videos and other things I can share. Just please feel free to email me and I'll send you all the details on how you can help collect pollen for us this spring and fall as well. So here is one of the graduate students collecting from linden trees with the ladder. It's a risky process. I don't want you to climb ladders. I want you to do something simplistic, less risk involved. And here is some pollen we collected from hemp when we went to WSU for a conference. Here is Dr. Karen also helping us, John Jacob, OSBA past president. So this is for fun, you can read. So one of those hemp plots, the research plots at WSU, they had this industrial hemp research plot, not marijuana, legal less than 0.3% THC, cannot get you high. Okay, this is my email. If you are looking, and you can Google and find or ask your leaders of your group and find my email and send me an email and be more than happy to help. So here is a take-home message for the nutrition part. Make sure your bees have access to adequate pollen throughout the brood rearing season. You don't have to worry in November, December, January, there is not much they do. They don't need that. But until October, make sure they have good source of pollen. If they don't, then you have to collect your pollen from the previous season. There are ways to do it. I'll show you in the next slide. So bear with me for 5 more minutes. I'm going to wind up. I know it's too late for you already. So use protein supplements if you're using with something that has 5 to 10% pollen rather than straight protein supplements that don't have any pollen. Just because of that sterols, right? I mentioned that sterol. If that sterol you need, then you have to have a pollen mixed in there. So either you buy something that already has pollen mixed in, or you collect your own pollen from a couple of strong hives the previous season. You're not collecting like tons of it, right? I'm talking about just a small cup of pollen with maybe a few tablespoons so that you can mix it with your protein supplement and feed them. So nutrition is really critical. Again, as I said before, when they're raising those winter bees. I'm not saying nutrition is not important now, but it's really important when they raise those winter bees, August, September, October. You have to make sure if you live in an area where there is not much pollen coming in, you may have to feed protein supplement mixed with pollen or collect your own pollen from the previous season when there is a lot of pollen foraging happening. Don't stress your hives by randomly collecting pollen whenever you want. You have to figure out when does your area get a lot of pollen coming in, like maybe July, part of June, maybe, I don't know, and then collect those pollen. So here are some tips. I'll go really fast. So you can use a front porch trap like this one. So we have used these in the past if you are collecting only small amounts. So you select a strong colony, not a weak colony, and then you put this thing on. So when you put this thing on, first day you have to allow them to reorient to, or orient to this. So this is a tray where the pollen gets collected. So this mesh that you're seeing where the bees have to go through, they squeeze through and then the pollen drops because their hind legs, the pollen baskets have the pollen, right? So when they squeeze through these meshes or these holes, the pollen drops into this. That's where you will collect in 2 days or 3 days, whatever your timeline is. So you have to keep this screen open. So this goes back. If you push it back and then put a tape on the side, then it will be open. So bees will just go through directly without going through the screen. But once they get trained after next day or so then you can put this in. But if you put this middle of the day, then they'll be confused. They'll go to other hives and you'll have a little more disaster created. So train them well before you start trapping the pollen. So next day, once they have had a entire day to go through this, then without having this, then morning they'll wake up and say, oh, this weird beekeeper has put something on, and they will try to fly through the holes and they'll come back to the holes as well. So install traps and wait. That's what I'm saying here. I'll be glad to share a PDF of this if you want, and you can follow those guidelines. And never trap pollen from weak hives and not more than 2 or 3 days from each hive. And always look for a strong hive that is facing the sun, has a lot of pollen foragers coming in. And once you collect the pollen, you can keep it at -20. That means in your freezer, and pollen has shown to be not losing any of the protein content or sterols and other things I talked about for at least a year. So if you store them properly in -20, you can use that pollen next year. So actually there is a publication that we have. You can Google, it's an open access. You should be able to, and all the tips that I mentioned, there are some videos as well in there if you want to watch. And we have a publication on bee nutrition as well. We wrote this for veterinarians because veterinarians are supposed to write prescriptions for you guys for bacterial disease antibiotics. So we thought there was a veterinary journal that was interested in writing an article for bee nutrition for veterinarians. So again, this is good for beekeepers as well if you're interested in reading this. It's an open access as well. And then last slide, I know probably some of you have heard about honeybee vaccine and you're wondering, oh, we are getting a vaccine soon. And so just take it with a grain of salt. Don't get too excited. This is still, I think, very preliminary. They have a good proof of concept, but I have not seen large scale studies with commercial beekeepers or hobby beekeepers to really demonstrate if it works in the hives at this point. They have done some very small scale studies, maybe with hives, and some good studies in the lab. So again, I'm not discounting any of these. I see a promise with this, but again, a good proof of concept. But again, don't think, I talked to this company recently and they said there will be a product they'll be selling soon, maybe this spring. I don't know if that's available yet, but yeah, you can try and see if, but again, American foul brood is a disease which many of you probably will never see or have seen in the past a little bit. But I would have been more excited if there was something like a vaccine for virus, like our COVID stuff, right? That would be more exciting. But of course, anyway, this is a new development. So I thought you guys will be interested. But again, take it with a grain of salt. So some reporters called me, so I gave some statements. You can read that. Again, need proof of concept. But again, I think we need to wait and see if it really works and how long does it, because they are basically feeding the queen with a candy incorporated with the vaccine. So it gets to the ovaries of the queen, and then when she lays an egg, that's how it's being. And again, as for your purposes, they don't have any, so we humans have antibodies, right? Insects are very primitive. They don't make antibodies. So that's a challenge. That's why they are feeding the queen, getting into the eggs. So there is this transgenerational concept they're looking into, is they can get to the eggs and that will sustain until that larval or pupal stages are coming out of that egg. So again, I'll not bore you with this, but if you have more questions, I'll be happy to answer. And I think I'm done with my talk here. Thank you very much.
Thank you. We had, we'll see what the room has for questions. We had one question in the chat, which was about a sugar, using sort of a, in lieu of an alcohol wash, a sugar shake. And if there was a specific volume of sugar to use per volume of bees, or is that kind of the information that's available on your website?
Oh yeah. We will give you all that information. How much, how many cups you have to use for how many bees you are using. It depends. You are using 300 bees or 100. So yeah, please watch those videos. And if you can't access, email me and I'll be happy to send you the link to look into all those methods, both alcohol wash and sugar shake.
Okay. Are there any questions here in the room for Dr. Sagili? Yeah. I'll repeat the question for you so you can hear it. The question was, do the larvae also need protein or do they just need carbohydrates? Reverse. Do the larvae need carbohydrates or just protein? So yeah, so bees will, so the protein is the main thing there, right? So the larva needs the protein, and the protein they're not eating, the bees will provide a small amount of protein that has been documented in later stages, like when you're more than 3-day-old larva, then you get a small amount of pollen directly. But most of their food is the brood food that is coming. So the nurse bees will eat the pollen. They'll grow these glands called hypopharyngeal glands in the head and the mandibular glands in their mouth. And those two glands are called exocrine glands. That means they open outside. That means they're opening to the mouth. And that's how the bee gets in and then regurgitates that food into the larval cell. So larvae are mostly feeding on the protein. That's where their that's their primary need. So they're feeding on the protein jelly. They're not directly eating too much of pollen. And is the pollen like that people find in stores the kind of something that you could add to a hive? Let's say someone is concerned about this. They want to add some pollen. They've got these protein patties. Is that something they can do or no? Yeah, that's a great question, actually. So it depends on what pollen it is. If you know the source and all, if I know most of the pollen gets irradiated because for the human consumption, it comes from China, or I think most of the pollen comes from China. So
I hope the irradiation process hasn't degraded any of the protein. So those are things which we don't know. But if you think there is a source, like there are some commercial, there is a beekeeper in California. We have bought some pollen from him directly for some research. If you get that kind of a source, which is local, and you know that that beekeeper is pretty good in terms of not having any chalk brood, or that's a major problem, is the pollen can get some contaminants like chalk brood, mummies, and then you can get an infestation of the disease in your hives. So I want you to be careful with that. So yeah, if you think you are pretty confident this has been irradiated, it's a good source, it has protein is not degraded, then yeah, you can probably try something that you get from a store. But I would recommend either trapping your own pollen or buying from some beekeeper that traps pollen and sells for a business.
Thank you. There's one more question in the chat. What is your opinion about the efficacy of Hive Alive? Also, thoughts on honeybee probiotics?
Yeah, so you have to remind me what Hive Alive is. There are so many companies that have started different things. So what is Hive Alive?
Jeremiah, can you add a little bit more, or come off mute and give us more info about Hive Alive?
Yeah, Hive Alive is a feeding supplement. It's got thymol in it, and also it's got like seaweed as additional feeding supplement.
Okay, got it. Yeah. So I know thymol, again, I don't know the purpose there, but if they're adding the seaweed, I think they are doing it for adding the sterols that I mentioned. Some people are, so some algae and all this spirulina, those type of things, they have a lot of, they have been documented to have sterols. So I think that's what the push is. I think some companies are trying to use that algae or spirulina, or in your case, you're saying it's some sort of algae or something that is mixed in there. So yeah, I don't know. We haven't tested, but again, some of these things you have to take it with a grain of salt until there is some good research comes around with these products. But as long as I tell people, as long as it's not killing your hives, if you want to test, you can test it. But again, none of these products have any scientific backing at this time. No one has really studied them in a controlled environment to show the benefits. So again, unfortunately, I can't comment much on that product. I haven't tested, and I have seen a lot of companies coming. And I think you're Jessica, right?
Yeah.
Yeah, Jessica. So was the other part of the question about probiotics?
It was just your thoughts on it. Yes.
Yeah. So probiotics, again, I see promise in probiotics, but again, same thing. We haven't seen any real robust studies that have shown the probiotics to be very effective at this time, because there is lactobacillus, there is bifidobacteria. These are two good bacteria that we think the probiotic should have. But then if you read the label for some probiotics, they have like 15 different bacteria, and some of them are not even seen in honeybee gut microbiome. So what do they do? Do they damage your bees, or are they just there for some reason? I don't know. So that's what some of these probiotic companies have done, is they have done a good job of at least getting some that we see, like lactobacillus species or bifidobacteria. But there are some which I have never seen in honeybee gut. So again, wait and see. As long as they don't damage your bees, again, you can try and tell me if that works. But we don't have any solid information on probiotics. But I'm again not saying probiotics are bad. I'm just saying we don't have good information at this point. Maybe wait for another couple of years. There are many other labs that are testing some of these probiotics. And once we get some good information, then you are free to use those products.
Thank you very much. Anything else here in the room? Dr. Sagili, thank you so much for joining us tonight. We're so appreciative of having you here in Oregon. We claim you as our own, of course. And obviously you're still at work, and I want to let you go and be able to go home and have some dinner.
Oh, no problem. No, it's always a pleasure. Yeah, next time I'll be in person. I'll not be on Zoom.
Yeah, that would be great. We're definitely gonna be more in person. I'm gonna take back the hosting here.
Oh, sure, yeah.
And certainly you're let's see.
Okay, then yeah. Should I stop sharing? I did, I think.
Yes, you did stop sharing. Maybe I'm host already. Well, we'll find out, I guess, when you.
Okay, I'll log off and.
Oh yeah,
yes,
reclaim host. Okay, I just reclaimed host. Thank you
okay,
very
yeah,
much.
Yeah, thank you all. Have a
yeah,
good night and
you.
good luck with your weeks. Yeah.
And anybody else online, you're certainly welcome to hang on for a minute as we chat and wrap up here. Such a great resource. We didn't sort of, I don't want to hijack. I was just going to say, kind of, we didn't necessarily have anything other planned. We'll certainly get some of the tech stuff situated in the coming months in case we do another Zoom speaker like this. But I certainly invite people to talk about like what you're doing in your hives right now, or oh, good. Maybe have his contact info again. Sure. I'll pull it up for you and I'll put it in the chat.
And it'll be on our website as well.
Okay, so go ahead.
Yeah, one thing that would be nice if you have a chance, if you feel that you're a mentor, find someone who feels that they're a mentee and at these live groups and start talking to each other. That's going to be really helpful for everybody going forward. And we ran a little bit late tonight. And Dr. Karen, you want to finish up with?
I'm not.
Okay.
And then we have a few things left over from our the corporate sale that we had in February that I bought. So if anyone wants other stuff like pipe bodies, sprays, unfortunately, I sold the last one of Dr. Karen's new edition books. I already sold that. I only have one for tonight. But I have some of the old edition ones. And we might even know
Well then, let's break for conversation, and I thank you for coming tonight, and look forward to seeing you at our next members meeting. Thank you.